Okay, what this exercise is doing is actually preparing you to gain an understanding of what's called Newton's method for getting an approximate root for some function like this. Um, let's see what they're asking you to do here. A solution, they tell you, can be found between x and 9, or 8 and 9. This is actually a portion of the graph of the function between, I don't know, from 4 to 10, this red graph. And if we wanted to find the equation of the tangent line at this green dot right here, which is on the function 8 comma negative 100, you have to find the first derivative and then use point slope. And point slope would say y minus y sub 1 equals m times x minus x sub 1. Well, we know the point, 8 comma negative 100, and we know that f prime is this formula. So if we plug 8 into here, we'll get the slope of that line. And so here are two values. The slope of the line is actually 307. So y minus f of 8, that would be the negative 100. So this is really y plus 100 equals 307 times the quantity x minus 8. That's his point slope right here. And if you plug in those values, negative 100 and 307, and then simplify, this is what you get. Okay. And if you want, when that tangent line crosses the x-axis, that will be an approximate root. So if we set this 307x minus 2556 equal to 0 and solve for x and call it x sub 1, we get 2,556 over 307, which is a decimal approximation is that. And so that's an approximate root. It's pretty close, okay? But we can get closer. This is where Newton's method comes into play. So if we get this little dot right here, which is on the graph, this is the point x sub 1, f of x sub 1, and draw its tangent line, it'll even cross the x-axis to a closer approximation for the root. This black rectangle right here is actually showing you the steps to do that, but let's go to the next board. Okay, so we want to find the equation of the tangent line at the point x sub 1, which was our first approximation, f of x sub 1. And to do that, we need to know the slope of the tangent line at x sub 1. And there it is right there. I called it M, 326, pretty close to that first first tangent line slope. But this is the steps you go through. Y minus y sub 1, that's this value right here, the y coordinate of the point on the graph that we're looking at, equals f prime of x sub 1, which is this 326, times x minus x sub 1. We can solve for y, and then we want to know, when does this equal 0? Well, it equals 0. Let's see, I could subtract this term from both sides, moving the f of x sub 1 over here, and then divide by f prime of x sub 1. That gives us this. And then add this x sub 1 to both sides. And there is the second approximation. So I've done that here, where I use the b is f of x sub 1. M is f prime of x sub 1. And I have the opposite of that over here, plus x sub 1. And this is how it normally looks right there. That's called Newton's method. Okay, and I'm going to share my screen. Go quickly to Newton's method for this guy. And here's You keep using these successive approximations. Here was our first. We started at x of 0 is 8. And then we applied Newton's method, which is this formula right here, n of x, our initial approximation, minus f of x over f prime of x. And then we keep using the new approximation to get closer approximations until they start repeating. And it looks like it doesn't take long. About the fourth approximation, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 decimal places. It starts repeating. Okay, so you were only asked to find this approximation right here. There you go.